Good afternoon, class. We are looking at exam 4 review, covering chapter 4, application of differentiation, chapter 5, integrals, and 6.1, areas between curves. Here's part 5. We're going to cover 5.5 and 6.1. We're going to continue with 5.5, the substitution rule. And we're going to delve into 6.1, areas between curves. So we remember that substitution is the reverse process of the chain rule. So anytime we have ln x involved, that would be the choice of u. So if you let u be ln x, the derivative of that is 1 over x, therefore du is 1 over x dx or dx over x. Now, I want you to look at both, because sometimes we see this one, sometimes we see this one. Is the same thing. I'm going to rewrite this so it becomes clear as to what we have. We have ln x to the second power and then 1 over x dx. This part is u squared. This part is du. Using the power rule, the answer is 1/3 u cubed, and you replace the u with natural log of x, and you're done. E to the power of x minus e to the power minus x over e to the power of x plus e to the power minus x dx. We want to integrate that. Notice you have a fractional expression. Anytime you do that, the very first step is to simplify if you can, and we cannot. In which case, notice the derivative of the bottom is the top. If I differentiate this one, I get e to the power of x plus e to the power minus x times -1, which gives us the numerator. Therefore, if you choose the denominator to be u, the numerator is du dx. So du is the numerator times dx. We put the top in a parenthesis times dx just to make sure we understand these two expressions are identical. The top is therefore du, the bottom is u, and we are looking at natural log. Replace the u, and you get ln of e to the power of x plus e to the power minus x plus c. Now, what's important for everybody to know, because this expression is always positive, you could put them in a parenthesis. We're going to evaluate this, and we are dealing with substitution at the same time definite integral, which is a number. So how do we do that? First, let's go through the substitution. Let u be 25 minus x squared. Du dx is minus 2x. So du is minus 2x dx. So I'm going to rewrite this such that x sits next to dx. As I said, in many texts, they solve for dx. I give you the easy way out. Minus 2 is missing, which is a number. Plug it in. How do you undo that? With its reciprocal, -1/2. So again, the product of this number, these two numbers must be 1. You can only do this if a number is missing. So what you're looking at is square root of u, du, -1/2 is in front. I'm not going to write the limits yet, and I will do that at the end. The point being, there are two ways to deal with a definite integral. You can go to the original variable, namely x, and original limits, namely 3 and 4. or you can create the new ones. We will do both in a moment. So first and foremost, square root of u is u to the power of 1/2. And that uses the power rule. So this remains. This one is 1 over 1/2 plus 1 u to the power of 1/2 plus 1. 1/2 plus 1 is obviously 3/2. And so we have 1 over that, which is 2/3. And you multiply that by negative 1/2, you get negative 1/3. And notice I haven't put the limits yet, because I can go back with 25 minus x squared and now use the original limits. That's one way to do that, and it's perfect. However, I want to know what the new limits are, and the way it works, you plug in number 3. You get 25 minus 3 squared, which is 9, and you get 16. You plug in number 4 into u, get 25 minus 4 squared, which is 16, gives you 9. So the lower limit is 16, the upper limit is 9. So you have a choice of going with the original variable or not. Original variable, use original limits. New ones, use different limits. So all you have to do, plug in 9, plug in 16. This is basic math. We're going to evaluate this. 9 to the power of 3/2 means square root of 9 cubed. This is 3 cubed, you get 27. This is 4, and cubed, you get 64. So 27 minus 64 is minus 37. With minus 1/3, their product is positive 37/3. So a quick recap. Go back to the original variable, use the original limits. Don't do that right here. Figure out the new ones. How? The lower limit goes into the u function, 25 minus x squared, and finds the lower limit, and the same as the upper. The integral of ln x plus 1 over x plus 1 dx, as the limits go from 0 to 1, and we are going to do the substitution anytime natural log is involved. That's the choice of u. And what is the derivative of ln of x plus 1? In other words, du dx is 1 over x plus 1 times 1. So du is 1 over x plus 1 times dx. Let's rewrite this so it becomes clear as to what we have in this fashion. And again, I hope everybody can see dx over x plus 1 or 1 over x plus 1 times dx, they are identical. So you're dealing with u du. And I'm not going to write the new limits because I can finish the job and go back to ln of x plus 1. However, if I want to find the new limits, I put the 0. If I plug in 0 here, I get ln 1, which is 0. If I put 1 here, I get ln 2. And that's an exact answer. ln 1 is 0, ln 2 is precisely ln 1. And of course, everybody knows that if you want to integrate, use half of u squared. So you plug in ln 2, 0 gives you 0. Or just plug in ln 2 and you write it in this fashion. Please understand ln 2 is inside the parentheses. Otherwise, ln of 2 squared is wrong. Okay, so ln 2 times the second power. Now, this is an exact answer. In calculus, we always answer it with an exact answer. If they said decimal and so many decimals, you do the rounding accordingly. We want to evaluate the integral of x to the power of 6 plus 1 dx as it goes from -2 to 2. And I want to remind you of something as far as even versus odd function is concerned. First and foremost, when you look at an even function, that means symmetric with respect to the y-axis. Odd function symmetric with respect to the origin. So in the case of an odd function, f of minus x is minus f of x. In the case of an even function, f of minus x equals f of x. And so even from the graph, you see that if it's an even function, the area from 0 to a and minus a to 0 are the same. So if you evaluate 0 to a and you multiply it by 2, that would be fine for the case of an even function. The integral of minus a to a f of x dx is 2 0 to a f of x dx. Whereas in the case of an odd function, this area is the same as this area, but this is considered positive, this is negative, and they cancel each other. So the integral of minus a to a f of x dx is 0 for the case of an odd function. So you can, and sometimes the functions are neither nor, okay? So you probably recognize this as an even function because the exponents are all even. This is exponent 6. This has exponent 1 times x to the power of 0. Okay? And so f of minus x equals f of x. You have to show that. So quickly, this is f of x. So f of minus x equals minus x to the power of 6 plus 1, which is x to the power of 6 plus 1, which is f of x. You have to show that so you can use this. If I want to evaluate it from negative to 2, it's a lot harder than evaluation from 0 to 2 and multiplied by 2. So this is harder than evaluating this from 0 to 2 and times it 2. I'm looking at this there. So integral of symmetric functions, if it's continuous, from negative a to a. And this is 1 over 7 x to the power of 7. This is x, and we're going to go from 0 to 2. 0 makes it 0, so plug in 2. If I plug in 2 to the power of 7 is 128 over 7 plus 2. Then you're multiplying it by 2. (284) divided by 7. You can write this as 14 over 7. And these two add up to 142 over 7 times 2 is 284 over 7 precisely. When you are dealing with something pretty complicated such as this one, the integral of negative 1 to 1 tan x 1 plus x squared plus x to the power of 4 dx, as it goes from minus 1 to 1 or minus a to a, you may recognize what type of a function. This is equal to 0. And why is that? All you have to do prove this function is an odd function. So let f of x be this function without the dx, of course, and calculate f of minus x. So if I change the x to minus x, f of minus x is tan of minus x over 1 plus minus x squared plus x. The denominator doesn't change, but the top becomes minus tan x. I hope you see that. If I replace the x with minus x, the bottom doesn't change, but the top is tan of minus x or minus tan x. And that is negating this one. You can put a negative in front of a fraction, and it's equal to minus f of x. We proved f of x is an odd function, and therefore it's 0. You don't have to do anything. Okay. Breathing. Anybody wants to read this for us, class? Okay. No one? We can model the rate of airflow into the lungs by the function f of t equals half of sine 2 pi over 5t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal volume, if the cycle lasts 5 seconds. And the note is the time for inhalation is half of the cycle. That means 5 halves, okay, because this is 5, half of it is 5 half seconds. Total amount of air inhaled is going to be from 0 to 5 halves, not 0 to 5, f of t dt. In this case, f of t is whatever that is given, everybody. F of t is whatever that is given. So we want to evaluate this integral. So if you let this one be the choice of u, the argument of sine is a choice of u. The derivative of that, du dt is 2 pi over 5. Du is 2 pi over 5 dt. So let's rewrite this integral by putting the 1/2 out and writing the rest of it. Now, this is sine of u, and I don't see the du here. I notice that if I had 2 pi over 5, then it would be the du I'm looking for. Again, in text they solve for it. You don't have to put the 2 pi over 5 here. 2 pi over 5 is a number, everybody. If I put 2 pi over 5 here, I put this reciprocal 5 over 2 pi outside. So I put 2 pi over 5 because I need it, and it's just a number. Its reciprocal 5 over 2 pi is outside. Again, the product of the two must be 1, and it is. So this is 5 over 4 pi. This is sine of u du. We're going to discuss the limits in a moment because I'm not going to use the original limits. I need new limits. So what are the new limits? If I put the 0 here, clearly this becomes 0. So 0 makes it 0. But what about 5 halves? Let's replace the t with 5 halves. In this case, 0 will easily give you 0. So this gives you the same thing. So if I put t equals 5 halves, it gives you 2 pi over 5 times 5 halves. And I hope everybody can see this is pi. So that's why we go from 0 to pi, because the integral of sine is negative cosine. We go from 0 to pi. So I'm going to put the negative out, and I'm going to write negative 5 over 4 pi, cosine of pi minus cosine of 0. Cosine of pi, negative 1 minus positive 1. This makes it negative 2. So positive 10 over 4 makes it 5 halves. So 5 over 2 pi. 5 over 2 pi. Now, on a normal basis, we want the exact answer. I want you to know that in calculus. If they ask for an approximation, and in a case like this, the reason they will, because even the formula is an approximation, okay? So 0.796 or 0.8, and the units. If you go back, this was liters per second. This is liters because this is the rate or the derivative function. We're going to evaluate these integrals, and I want you to be exposed to them side by side. We are dealing with sinusoidal functions. However, in the first case, it is the argument that has an exponent. So let u with the argument of sine, which is x squared. You know its derivative is 2x, therefore du is 2x dx. So we are going to write sine x squared, and we're going to move the x next to the x. And again, instead of solving for dx, I just notice I have everything except number 2. So I'm going to throw in number 2 because it's a number. Also, I need its reciprocal 1/2. And again, whether you put the 1/2 inside the integral sign or outside makes no difference, just the coefficient. So this is sine u, this is du. The derivative of sine is cosine, but the integral of sine is negative cosine. So minus 1/2, this takes you to a negative sign. Minus 1/2 cosine u and a constant. So that's what we get. Replace the u with x squared and you're done. What about here? When you have sine and cosine involved, both of them, the one that has an exponent is a choice of u without the exponent. Sine means, okay, I want to make sure we understand. This means sine x to the second power. So u is sine x. What is du? Cosine x dx. So what you're looking at is the integral of u squared du. And that's a simple case of a power rule. 1/3 u cubed plus a constant. So 1/3 sine cubed x plus a constant. Now, what I want you to see, again, I want you to see them side by side, so compare and contrast. And if you look at this one, understand it is cosine x that has a power of 20. Therefore, the choice of u is cosine x. What is du? Minus sine x dx. And I'm going to leave it for you to finish that. This is very similar to that. When sine and cosine are involved, the one with the exponent is a choice of u. What about the integral of tan x dx? We are going to rewrite this as sine over cosine. It is important to know that dx always belongs to the numerator, is not part of the denominator. So u is cosine x, cannot be sine x, because du is minus sine x dx. And again, dx belongs to the top, not the bottom. If you choose u to be sine x, granted the derivative is cosine x, but then du is cosine x dx, and dx is not part of the denominator. So be very careful with that. Dx can never, ever be in the denominator, okay? Or dt for that matter. And so we are going to rewrite this as follows. So we're going to write this as 1 over cosine x and then sine x dx. And since u is cosine x and everything looks good except we don't see the sign negative. So I'm going to throw in, negative out. Their product is positive 1. We are in good shape. Okay. So the negative sign was missing. We took care of the business. It's not a big deal. So we have minus 1 over u du. And as you know, this is a natural law. So minus remains, minus ln of absolute value of u plus a constant, where u is replaced with cosine x. And that's extremely important to know. Now, furthermore, we can write this one, cosine x to the power of negative 1 or 1 over cosine x or secant x. I'm going to quickly remind you what I'm talking about. If you have, let's say 5 ln x is the same as ln of x to the power of 5, right? So that's what we are doing here. So we are going to rewrite this as ln of cosine x to the power of -1. And that becomes ln of 1. Of course, everything is in the absolute value, okay? 1 over cosine x. 1 over cosine x is secant x. So just wanted you to know, okay? All right, so those are substitutions. Let's switch gears, go to the area of the region between the two curves. Let f and g be continuous functions with f being larger than g, meaning it's above g. From a to b, that means it doesn't matter what happens afterwards, we're just interested in a given interval. Then the area of the region between the two curves from x equals a to x equals b is this one. Take a look. This is the area between f and g. This is the area under the f function. This is the f function. F is larger than g, that means it's above it. This is the area under g, the red one, and this is between the two. So the area of this region is the integral of a to b f of x minus g of x dx, because this one is the integral of a to b f of x dx minus this one, which is g of x, the integral of a to b g of x dx. That's the concept. So you want to find the area of the region between two curves. What do? Number one, graph the two functions. Always graph. Doesn't have to be perfect. Just sketch them, and it's a rough sketch that's good enough. Find the points of intersection. How do you find it? Set f of x equals g of x, and so on. Then evaluate the integral. For example, look at this one here. Clearly, we're going to go from a to b. So I'm reminding you that this limit is this integral, okay? By definition. So if you want the area between a and b, you make up some sort of a thick layer which has some height, some width. The width, I'm going to call it dh in general, and the height, I'm going to call it h in general. It so happened the height is f of x minus g of x because f is at top of g of x, and dh happened to be dx. The reason I like to use h and dh, because you figure out what is h, you figure out what is dh. dh is always dx or dy. So the area of a typical rectangle, we call this a typical rectangle, is y of the t, that means y of the top, minus y of the b, y of the bottom. So if you look at this height, y of this top minus y of this bottom, times the width, which is delta x, and the equation goes like this. dA, I'm going to call this an increment of area, is h dh. So the integral of a to b h dh is the answer. Now what is h? H, according to this, is y of the top minus y of the bottom, and dh is dx. However, it could be x of the right minus x of the left times dy. So if the function, if one is at top of the other, we go with this one. If one is to the right of the other, we go to this one, okay? This for this graph, okay? It's very straightforward, in which case becomes f of x minus g of x times dx, okay? So this is h, f of x minus gx, and this is dh or dx. So that's all you need to figure out. Now, when you sweep this, take a look at this rectangle. If you sweep it across the x-axis to cover the shaded region, then the width is dx. If you go up and down, the width is dy. You'll see that as we look at some examples. Let's start with a very simple example. We want to find the area of the region bounded by this graph, y equals 2x squared minus 3x plus 2, and the x-axis, and x equals 0 and x equals 2. It is extremely important to have the graph. And I'm assuming it's a parabola, everybody can graph it. You can even use a graphic calculator. You should have no problem with the graph class. So here's a graph of y equals 2x squared minus 3x plus 2. We want to cover this area the area bounded by the region of this function, the x-axis. This is the y-axis, or x equal to 0. This is x equals to. So that's the region we want. Okay. This is the shaded region we are interested in. So we draw a typical rectangle. And it doesn't matter where you put that, where you do the drawing class. You can draw it here. You can draw it here. You can draw it here. Anywhere you want to draw it, okay? So this is, by the way, this is the vertex. And as you recall, the vertex has x equals minus b over 2a. Okay, this is ax squared plus bx plus c. Okay, and then you plug it in and you find the y coordinate. So finding the vertex shouldn't be a big deal. Okay, so here's a typical rectangle. I'm going to erase the mess so you can easily see everything. Okay, and when you look at that, everybody, this has some width, this has some height. Clearly, the height is the function f of x over y minus this function. This function is 0. So that would be the height and the width. Look at this rectangle. You have to move it to the left and right. So the A is h dh. H is y of the top minus y of the bottom. So this is y of the top, which is this function. Y of the bottom is the x-axis, which has equation y equal to 0. So this is your height, f, or this function minus 0. So 2x squared minus 3x plus 2 minus 0 times dx. This is understanding what we have. Instead of memorization with that part, I like to go with HDH. I draw this one, I figure out what is my height, what is my DH. DH is always dx or dy, one of the two. And I'm going to integrate from A to B, 0 to 2, from here to here. It's a very simple case of integration. So this is 2/3 x cubed minus 3x squared over 2 plus 2x from 0 to 2. If you plug in 0, it becomes 0. So just plug in 2 minus plug in 0. So plug in 2. 2 cubed is 8 times 2, 16 over 3 minus 2 squared, 4 times 3, 12 over 2 is 6, and 2 times 2 is 4. Put them all together, we get 10/3. I'm assuming we have no problem adding these numbers, okay? Here's another example. We want to find the area of the region that is bounded by the graph of f of x equals 2x plus 1, and g of x is x squared plus 1. F of x equals, or y equals 2x plus 1 is a line with the y-intercept at 0, 1, and x squared plus 1 is just y equals x squared shifted up by 1. I'm going to assume nobody has any problem graphing the two. So number 1, graph the two functions. Looking like that. Number 2, we want to find points of intersection. So to do that, we set them equal. Now, to solve this, we take everything to one side, or somehow we solve this. It's better to take them to one side. Of course, the 1 drops everybody. So it's x squared minus x equals 0. If you factor the x out, you get 0 and 2. So it's either 0 or 2, meaning if x is 0, plug it back into this one or this one to find the y. In either one, and actually you plug it into both to make sure they're identical. So this point has coordinates 0, 1, and this point has coordinates 2, 5. If you plug in 2 here, you get 5. If you plug in 2 here, it's 5. So find the two pairs. Needless to say, you don't need both of them. You either need or x or y, depends whether you sweep it along the x or y axis. So here's the next step. We want to evaluate the integral, but first we need the dA, okay, which is HDH. Class, dA is HDH. So here's the height, here's the width. The width, look at this one. We are going to go left and right, yes? So maybe another one here, and just throw out 2 more. For example, you may just do it right here. You may do it right here. The point is, you're sweeping this along the x-axis. So the h is the x. But what is the h? H of the top function, which is the line, minus h of the bottom function, which is the parabola. So y of the top is 2x plus 1. Y of the bottom is x squared plus 1. And the only thing that gives me the correct answer is the graph. So y of the top comes from the line, y of the bottom comes from the graph of the parabola. So h is f minus g. Here's f, here's g. 2x plus 1 minus x squared plus 1, and then dx. So put it into a integration sign and evaluate it from 0 to 2. To do that, let's simplify. This is 2x minus x squared. These two cancel each other because plus 1 minus 1. Very simple case of integration. This is x squared minus 1/3 x cubed from 0 to 2. If I plug in 2, I get 2 squared minus 2 cubed over 3. 0 just gives me 0. And so this is 4 minus 8/3. Or 12/3 minus 8/3 is 4/3. Very straightforward, everybody. So that's how you find the area between the two curves. Find the area of the region bounded by the graphs of x equals 3 minus y squared and y equals x minus 1. The very first step is to graph the whole situation, the setting. I can't emphasize the importance of that. Now, graphing this line is very simple. Graphing this, remember what this is. This is a parabola that opens sideways because y is of degree 2, and because it has a negative value, it opens to the left. So first and foremost, Here's the graph of y equals 3 minus y squared. I hope you remember how to graph that. Y equals x minus 1 is a line, or x equals y plus 1. I'll tell you why I changed it to that one, but for now it doesn't. I just graph this. When you graph this, so you have this function, you have this line, and you want the area that is bounded by the graph. So you want this area. Okay. So you want this shaded region. So f of y, or x equals y plus 1, that's the line. G of y, or this one is 3 minus y squared. We make it a function of y. The reason we make both of them function of y, this is a function of y, and this one we change it so that we use it in the same manner. Now we need a typical rectangle. We also need to know points of intersection. So to find points of intersection, you have to set them equal, of course. So this is x, 3 minus y squared. This is xy plus 1. Put these two equal. And bring everything to the same side and put them in descending order. So if I take everything to the right, 0 becomes y squared plus y. This is minus 3, so 1 minus 3 gives me minus 2. I take everything to the right. So I put it in descending order, and I want y squared to have a coefficient which is positive. I'm going to factor. So this gives me y equals 1. This gives me y equals negative 2. So I have actually the points that I want. I don't need the x coordinates, but I'm going to show you how to find the x coordinates. It's very simple. Y is 1. If you put it here, x becomes 2. By the way, if you put it here, you get the same thing. Y is negative 2 plus 1. X becomes negative 1. So we have those two pairs, everybody. Okay? A typical rectangle, you see that clearly the parabola is on the right side of the line. Why don't you come up with a vertical rectangle? Because here the line is at top of the parabola. But if you go here, parabola is what? At top of the parabola? How do you do that? It's impossible to do it that way. Therefore, you go with the following. Here's your typical rectangle. Here's the width. Here's the height. The height is the x of the right minus x of the left, or we call this the g function, g of y, and we call the line f of y. So this height is g minus f, and this one, you're going to sweep this way, right? Up and down, right? This rectangle, you have to sweep it up and down to cover this graph, this shaded region, therefore dy. So you have x of right minus x of left, g minus f, 3 minus y squared minus y plus 1, dy. And of course, we are going to integrate this from the very bottom to the top. The very bottom y coordinate is negative 2. The very top y coordinate is the y coordinate of this point, which is 1. So it's important to know the limits. So the limits of the y. If you want to put this in a descending order, it's minus y squared. Then let me just write this as minus y minus 1. So we have minus y squared minus y. 3 and negative 1, they add up to positive 2. It's a simple case of a power rule, negative 1/3 y cubed minus 1/2 y squared plus 2y. You're going to plug in 1 and you're going to plug in negative 2 and you get to the answer. So here's what's going to happen. Negative 1/3 times 1 cubed minus 1/2 times 1 squared plus 2 times 1 minus negative 1/3 negative 2 squared minus 1/2. This was negative 2 cubed. Negative 2 squared plus 2 times negative 2. I'm going to assume, and this is, put a negative sign here. Do the math, you end up with 9/2. Okay. By the way, if you end up with a negative number, you're wrong because this clearly represents the area between the two curves. And this is elementary algebra. I'm going to assume you can do that. So this is minus 1/3, this is minus 1/2 plus 2, and so on and so on. Find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. Again, we have to graph to see what's going on, and g of x equals x, that's the line that goes through the origin, and 2 minus x squared goes like that, minus x squared comes down, and then shooting up by 2. So it's very easy actually to graph this. Even in your head, you can graph it, you don't need the calculator. So we're going to set the two equal in order to find the points of intersection. And this is a typical rectangle. Y of the top minus y of the bottom and so forth. So let's find points of intersection. You set it equal, let's bring everything to the right because I want to make this positive. Okay, that's why I'm going to move it to the right. And it's a simple case of x plus 2 times x minus 1. And you set that equal to 0. So it's x equals negative 2, x equals positive 1. If I plug in negative 2, it's easier to put it in here. G of x of y is the same. So this is negative 2, and this is positive 1, 1. And by the way, it's a good practice to check it with this. If I put negative 2 here, I get positive 4. 2 minus 4 is negative 2. So that works the same thing for the 1. We always want to check it with both functions just to be on the safe side. And a typical rectangle, here's the height, y of the top minus y of the bottom. So this function minus this function, f minus g, where f is the parabola. The parabola is at top, 2 minus x squared. The line is at the bottom. So y of the top minus y of the bottom times dx. The reason is dx because this rectangle, you sweep it across the x-axis. So this width is dx, and this h is f minus g. So 2 minus x squared minus x. And we are going to evaluate the integral from this point to this point, the x coordinate of this point to x coordinate of this point. This is 2x. This is minus 1/3 x cubed. This is minus 1/2 x squared. And we're going to go from -2 to 1. I'm going to quickly show you, but I'm going to just give you the answer. So you plug in 1. So we get 2 times 1 minus 1 cubed, which is 1 over 3 minus 1 squared over 2 minus 2 times -2 minus -2 cubed over 3 minus -2 squared over 2. And when you do the math, you end up with 9/2 again. Okay, that's the key, everybody, is to find and understand this typical rectangle. And this typical rectangle has the width and the height. The width is always dx or dy. So if we go along the x-axis is dx, along the y-axis is dy. And the height is the function at top minus the function at the bottom, or the function on the right minus the function on the bottom. We want to find the area of the region between these graphs, f of x equals 3x cubed minus x squared minus 10x, and g of x equals minus x squared plus 2x. You can graph this, okay, and you can even use a graphing utility. So f of x is 3x cubed minus x squared minus 10x is this function. And the parabola minus x squared plus 2x is this function. And we need to find points of intersection by setting them equal and solve. Since this is minus x squared, they cancel each other. I can factor out the 3x. So x is either 0 or x is plus minus 2, because x squared minus 4 means x squared equals 4, or x is plus minus 2, or x plus 2 times x minus 2. So there are 3 answers. 0 is the easiest. If you plug in 0, you get 0, 0, or both of them. -2, you plug it into this as well as this one to find the y coordinate. 2, the same thing. 2 happen to give you 0. 2, it's clear if you plug in minus 2 squared is minus 4, and it works out. So you find those 3 points, and those are the coordinates. Again, these two were extremely easy. Put the -2 into this and then check it with this. You have to find in both cases -8, okay? Those two, they were easy to find, those two. Although you really don't need the y coordinates, okay? But I like to go with the coordinates. Now you want to evaluate the integral by coming up with a typical rectangle, which looks like this. Y of the top minus y of the bottom times dx. This is h dh. Here's the height. Here's the width. The width, because this is going to sweep along the x-axis, the width will be dx. But what is the height? Well, this is very interesting. You have to put this in absolute value. Here's the reason. If you look at this one, class, the top is the parabola, the bottom is f of x. In other words, for this part, we go with g minus f. But this one, what is at top? The cube function is at top. So f minus g. So the h varies. For this one is f minus g. For this one is g minus f. For this one is g minus f. So from negative, so in this part, we're going to go from -2 to 0. In this part, we're going to go from 0 to 2. So please understand what happened. We made up two integrals. One more time. This one, the top function is the f function. Okay. And this minus that, we actually worked it out. So this is 3x squared minus 12x. Let me just this is what we use here. And we use the parabola is at top. G minus f is the negation of that. Notice I put minus 3x cubed plus 12x. Minus 3x cubed plus 12x. And that's extremely important to understand. Okay. So with that being the case, let's do the math. This one is 3 over 4x to the power of 4 minus 6x squared from -2 to 0. This one is minus 3/4 x to the power of 4 plus 6x squared from 0 to 2. Just plug in 0, plug in -2, the same thing here. Just at this point is elementary algebra class. You can plug in and evaluate each case. Okay. We end up with 24. The key here is that you can't integrate from -2 to +2 with one function. -2 to 0 is different than 0 to 2. We have, in this case, f minus g, in this case, g minus f, and you want to be careful.